Hello! This video will provide an introduction to how to perform psychometric analytics using classical test theory, leveraging the powerful software platform Iteman. Today I'm going to be talking about the results that come out of Iteman version 4.5, which was released in January 2022. But a lot of what I'm going to be talking about pertains to earlier and most likely future versions of Iteman. Because it discusses the principles of classical test theory, which have been around for decades. Classical test theory was originally developed before World War II, the basic principles about it. And it's based off of standard mathematical concepts such as proportions, averages, standard deviations, and correlations. But nevertheless, it still provides a powerful and compellingly easy way to evaluate Iteman test performance. However, if you're doing professional level of work, you most likely need item response theory, in which case you should be looking at the software platform Excalibur as well. Excalibur performs much of the same analyses, but then also does item response theory analysis on top of it. There's a separate video that talked about how to run Iteman. This video will just discuss how to interpret the results. So you see I have here the folder with Iteman, including the input files that I used in my previous run. And I've got output files, which I did a run called new1 and I did a run called new2. And I'm going to be looking at new2. So you can see there's 3 files in each one. The scores file, as you would imagine, just produces the scores for each examinee or candidate in your data set. So in this case, I had 60 people in my data set. So it gives the sequence, their ID number or name, depending on what you're using, how they scored on all items on the test. So this test had 40 questions, and it had 6 or 8 pretest questions, which means you're just checking how many pretest questions each person got right, as well as the number of scored items they got right. It provides the proportion correct of the scored items. It gives the overall rank of the candidate in terms of the free distribution. Gives the percentile rank. It divides the candidates up into groups used to create the quantile plots, which I'll talk about later, and tells you what group they're in. It provides the domain scores. So this examination had 3 domains or subscores. And it also provides classical conditional standard error measurement values, which aren't that really useful, but the discussion of that is beyond the scope of this presentation. The second file that it provides is comprehensive classical test analysis, which uses classical test theory as we talked about before. And this provides overall summary information you see up here, summary statistics, reliability analysis, item statistics in a row format, and then item statistics in a table format, depending on which you prefer. This row format is extremely useful if you need to take these statistics and import them into an item making platform or other database. But otherwise, it's also useful if you want to use it to sort the results. So like I can select items here and then go to data sort and say I want to sort by p-value. And you can see here p-value is this column, so it's sorted all of the items by which is the hardest up to which is the easiest. But the most important file that comes out of Iteman is the Microsoft Word technical report. And this is where the true value of Iteman lies. It saves the time that is involved in creating a tech report from Psychometrician, because otherwise you're going to be calculating statistics, making graphics, and doing a lot of copy and paste to put them into Microsoft Word and make some explanations and narratives. So what you see here is actually the direct output of Iteman. It's not embellished in any way. It starts by providing a nice professional title page, including the title of your run or your title of your test. Then it provides an introduction. Most of this is to provide a background of what you're doing, just to let you know what you're looking at. The next section provides specifications, which is mainly for historical purposes. So if you need to come back and look at this, a year later, so you can do next year's run, you can remember what options you put in this time. Otherwise, it'll be very difficult for you to remember because there's just so many options in Iteman. So it gives us some summary info like 60 examinees, 34 scored items, but it's also giving us some important information such as responses begin in column. What was the omit character? Was it O or an S or something else? Did you, correct for spuriousness, yes or no? All these are different options that you can set in Iteman. And then it provides summary statistics at the test and domain or subscore level. So you can see, first of all, it gives us classic descriptive statistics, such as average score. In this case, it's 33 out of 40, standard deviation, minimum, maximum, mean p-value, and mean point by serial discrimination. And it does that for the overall data set, the scored items, which is what really matters, the pretest items, and then each of the subscores as well. Then provides the same breakdown, but for reliability analysis, including coefficient alpha, standard error measurement, and split half using 3 different ways of doing split half, and then the Spearman-Brown step up of those using split half. You can see that the overall assessment was okay reliable, and that it's got a reliability of 0.719, but the domain scores for domain 1 were actually pretty unreliable at 0.224. Next, Iteman provides an automated list of items that didn't meet criteria of being good questions. As I described in the other video, you can specify what constitutes good as questions for you based upon what range of p-values and point by serials you're going to allow. In this case, you can see that it's flagging items for being too hard, too easy, or having low point by serials. So in this case, LR is low R point by serial. K means that the point by serial for one of the correct answers, or the p-value for one of the correct answers, is lower than it is for an incorrect answer, which often indicates that there's a possible key error. And then, there's also LP for being low P and HP for being too high of a P. Then provides distributions of scores for the total score, for each of the subscores like you see here, 1, 2, and 3. Provides correlations of the subscores as a rough evaluation of the unidimensionality of the exam. Provides a distribution of the p-values. In this case, this test was overwhelmingly easy. Provides a distribution of the point by serial values. And then it provides a bivariate plot of the p by the point by serial, because typically items that are too easy or too hard will have low point by serial. And then it provides that classical standard error measurement that I mentioned. That's if you want to use that. Then it gets to the most important part of the Iteman output, and that is the item-by-item results. And what this does is, you can see, gives you output like this, where we are looking at a quantile plot of the item performance, and then looking at very specific statistics about the item performance. So the quantile plot works by dividing the examinees up into 4 groups, 1, 2, 3, 4, and 5, with 1 being the lowest 20% and 5 being the highest 20% in terms of the total scores. And then it graphs how many from each of those groups selected each of the responses in a multiple choice question. So what this graph is saying here is that most examinees selected A, regardless of what group they were in. That's not always the case. You'll see items like item 2 here, which is more typically what you're going to see. Not as many candidates selected the correct answer D in group 1, because that's low performing, but for group 5, which is the top candidates or top examinees, everyone got it right. And that's kind of what you'd expect to happen with a test question, because the top examinees, top students, should be getting the question right. And then the incorrect answers, or the distractors you see, are sprinkled down here at the bottom. Not as many people answering that. Since we only had 60 people in this data set, these aren't necessarily nice smooth lines, but if you were to have a data set with like 50,000 students, these lines will often go quite smoother, and you can even extend this to having more groups than 5 to get a cleaner line. Now, what do these numbers mean? You can see the first table provides just background information of the item, like what was the ID or name of the item, what was the correct answer, was it scored or pilot, how many options did it have, and what domain does it belong to. If it has flags, the flags will be shown here. Then we provide summary statistics on the item, the number of candidates that attempted this item, which was 60 here, the p-value, which is the percent or proportion that got it right, the domain point by serial, the domain by serial, the total point by serial, and the total by serial, and then the alpha without, which is the alpha reliability of this exam if this item was taken out. And then where it gets really useful for diagnosing problem items is this option statistics down here. So this is telling us that 3 examinees chose A, 1 chose B, 3 chose C, and 53 chose D, which is what you'd expect since that's the correct answer. The proport column converts these to proportions, and then it provides the point by serial and by serial for each of these, as well as the mean and standard deviation of scores for people that chose each of these. And typically what you're going to want to find, what you want to look for, is that the correct answer has a positive point by serial and the incorrect answers have negative point by serials. In this case, answer number C had a slightly positive point by serial, but again, that's because there's a low sample size here with only 3 people. All it takes is one high quality candidate getting this, choosing C to throw off that point by serial. And it tells you what color these are, looking at the results so that you can interpret the result a little more efficiently. So this is an example of a good quality item, a little bit on the easier side, and that 88% got it correct. We can also look at item number 39 here. It's a good example as well. In this case, only 73% got it correct. And again, you see that nice line going up for the correct answer. In this case, it's B. And the answers, or the lines for the incorrect answers, are going down, A, C, and D. That's what you want to look for with a high quality, well-performing item. We got a positive point by serial for the correct answer, negative point by serial for the 2 incorrect answers that have responses, and then nobody chose D at all, so that there's no statistics for that one. Note that in this case, 5 examinees did not take that question, they just omitted it. Then item number 40 is a good example of a miskeyed item. So in this case, we had 48 people chose B with a positive point by serial, but only 10% chose D, which was the correct answer. So most likely this one had the key incorrectly typed in when the item was written. And you might want to go fix this in your testing platform or whatever using produce scores and rescore the candidates that they're getting an appropriate score. And this is where Iteman becomes really useful because it allows you to diagnose problems like that. In this case, it's a miskeyed item. It's quite obvious, but in other cases, you might have an item where there's 2 answers that are arguably correct. And you might have 40% choose B and 40% of the students choose C, and they both have a positive point by serial discrimination. Iteman allows you to find those types of situations and effectively diagnose what you want to do to fix those questions. So that is an overview of how to use Iteman and classical test theory in general to improve your assessments. If you're interested in making this even easier, our online assessment platforms, FastTest and AssessAI, have this Iteman report built into them, which means that if you deliver an online test, all you have to do is go to a report screen and say, print me this report. And it doesn't take any running of the running of the software or formatting the results. It's just that easy. And then you can immediately take this up on screen like I have right now, show it to your content experts, and start reviewing your test questions. So thank you for taking the time to watch this video, and I hope you watch some of our other videos. And also, if you have a chance, please subscribe. Thank you.